Hey guys, I bet you're excited because we are graphing rational functions and it's probably the most exciting thing you'll do today, right? All right, first I want to give you an idea of what these graphs can look like. Obviously, this is not all the ways they can look, but I wanted to give you an idea about what your graph might end up looking like. So here's 4 different examples. Let's see how this one turns out. So when we graph these, we follow 4 rules. First, we're going to factor, then we're going to find our asymptotes, check for holes. Then we're going to find our x and y intercepts. And last, we're going to figure out the general shape of our graph using our preferred method, which we will talk about once we get there. So first thing we're going to do is factor. I will link a video in the corner for you if you need a factoring review, but I'm just going to tell you the top's going to stay the same, right? X plus 3 on top. And the bottom is going to factor to x plus 2 times x plus 6. There we go. We are factored. So the next thing we're going to do is look for our asymptotes and holes. So a hole in our graph occurs if, pretend when I had factored this, that this had been an x plus 3 here, so those would have canceled. That is when you have a hole in your graph. So this example does not have one, but I will link an example in the corner if you want to see an example where there is a hole in the graph. But we checked here, there were no holes. All right, our vertical asymptotes. This has to do with, if you've been doing math, you know that we do not mess with zeros in denominators, right? They do not make us happy at all. So vertical asymptotes are formed where this would be equal to 0 on my denominator. So how do I figure that out? Well, I set these equal to 0, right? So I'm going to have x plus 2 equals 0 and x plus 6 equals 0. All right, so to solve this, I would subtract 2 from both sides and get x equals negative 2. This one, I would subtract 6 from both sides and get x equals negative 6. So those are my 2 vertical asymptotes. I represent these on my graph with a dotted line. So here we go. Now, when you graph these on a graphing calculator, you may not actually see a dotted line. This is how we like to represent it when we're graphing it by hand. But you may not actually see it on your calculator. You'll just notice that the graph gets closer and closer to these areas. So there is my asymptote at x equals negative 2. Now we'll draw one at x equals negative 6. Okay, your graph will not cross these vertical asymptotes. If you end up with your graph crossing it, go back and check your math. You must just have a miscalculation somewhere. All right, there are those. Next thing we are looking at is our horizontal or slant asymptote. You will not have both. Guys, I have been struggling to draw brackets lately. So there you go. That's a bracket. You will not have both of these. To figure out what we have and what it is, we follow some rules. Yes, we love it when we have rules, right? But these did not come out of thin air, right? I will link a video in the corner for you if you're wondering where these rules come from. All right, so when we're figuring out our horizontal or slant asymptote, we look at the degree. So the highest exponent on the top and the bottom. So on the top, the bottom, sorry. The bottom, my highest exponent is 2. Now you might say, oh, it doesn't look like there is an exponent on top, but this is really x to the first. So I have a 1 on top. All right, if my top degree is greater than the bottom degree, I don't have a horizontal asymptote, we check for a slant. If the top degree and bottom degree are equal, we divide our leading coefficients. If the top degree is less than the bottom degree, like in this example, my horizontal asymptote is at y equals 0. So that is what applies to this problem. My horizontal asymptote is at y equals 0. And again, we represent that with a dotted line. In this case, it's right on the x-axis. So it can kind of be hard to see, but we'll try to make it so you can still see it a little bit. Now, interesting fact you need to know about horizontal and slant asymptotes. Oh gosh, guys, that shouldn't stick up that far. Oh well, it's fine. Is that horizontal and slant asymptotes can actually be crossed sometimes. Vertical ones, absolutely not. Horizontal and slant can sometimes. Now, if you're thinking, Why do we have them if they can be crossed? That's dumb. I thought the same thing. They still help us figure out the shape of our graph and help us know where our graph is approaching. So they still matter, even if they can be crossed. All right, we found our horizontal. Because there is a horizontal asymptote, there is not a slant asymptote. All right, look at us. We are just making progress here. We are already to our intercepts. Okay, so to find our x-intercept or intercepts, there could be more than one. I am going to set y equal to 0. So I'm going to have 0 equals x plus 3 over, I could write this either way, it doesn't really matter, x squared plus 8x plus 12. Now, I don't really want to deal with that big fraction, right? And I'm trying to get x alone, so I would multiply both sides by this x squared plus 8x plus 12, right? X squared plus 8x plus 12. Then those guys go ahead and cancel. 0 times that is just going to give me 0, so I have 0 equals x plus 3. Woohoo, right? Then I go ahead and subtract 3 from both sides and get x equals -3. Now, this is a point, right? This is my x-intercept. It's not a line like my asymptotes. It is a point. When I plugged in 0 for y, I got -3 for x, right? So that tells me that I have a point right here. So you can see right off, we have a point that crosses that horizontal asymptote, right? Which is okay. We can't cross the vertical ones. Horizontal is okay, all right? Okay, we found our x-intercept. Let's look for our y-intercept. So for our y-intercept, we are going to set x equal to 0. So we're going to have y equals, and again, I can plug it into either one, 0 plus 3 over, I'm just going to use this one, 0 squared plus 8 times 0 plus 12. So I end up with y equals 3 on the top. 0 squared is 0. 8 times 0 is 0. Plus 12, so I got a 12 on the bottom. And that simplifies down to 1/4. So when I plugged in 0 for x, I got 1/4 for y. And we're totally not panicking that that's a fraction. We can handle it. So I know that my graph also crosses the y-axis at 0, 1/4. It doesn't have to be perfect, just about there, right? Okay, now what? I've got some asymptotes. I've got 2 points. Now what? Now is when I need to figure out the general shape of my graph. So I really need a graph representing all along here except where my asymptotes are, right? Because I could plug in -100 for x and I would get a y, right? Or I could plug a number between here and there for x, I'd get a y. I could plug in a number over here for x and I'd get a y, right? I need to have my graph represented everywhere except at these spots where it would make the denominator 0, which is why we have those asymptotes there. So how do I figure that out? Well, first of all, the first thing you can do is pick some points. Pick some points to the left of this asymptote, pick some points in the middle and some over here to get the general shape. That is one method. Another method is just to apply what I know about functions and about asymptotes to help me figure this out. So if you want to do the points method, go for it. I'm going to show you kind of this other way to just think about it kind of logically. So I know I need a graph over here, right? And it's going to be either up here like this or down here like this. I know that because I've graphed these a lot, and I also know that I found my x-intercept, right? And it was the only one. So I know my graph is not going to cross here, but it's still going to approach this vertical asymptote. So it's either going to do it down here or up here. So what I need to know is when I plug in a number that's over here, will my number, my output, my y, be positive or negative? I'm not too concerned right now about what the actual number is. I just want to know if it's positive or negative. That'll tell me if my graph goes like this or like this. So we're going to do what's called sign analysis. If you don't like this, like I already said, pick a point, plug it in, get the actual number. But we're going to do this sign analysis way. So let's just go ahead and pick -10. So if I plug in -10 here, and I'm just worried about the signs. So -10 plus 3 would give me a negative, right? Over -10 plus 2 would give me a negative. -10 plus 6 would also give me a negative. So I have a negative on top. A negative times a negative on bottom would give me a positive. And then a negative over or divided by a positive gives me a negative, right? Okay, so what does that tell me? When I plugged in -10, I got a negative number. I don't know exactly what that negative number is, but I know it was negative. So it's below, right? And I know it's not going to go back up because that would be another x-intercept. And I already found my only one, okay? So knowing that a -10 gives me a negative y tells me that this graph is going to approach this asymptote in the negative direction. Like that. Okay, so we've got from -infinity all the way to this asymptote covered, right? It's not perfect. It doesn't have to be exactly perfect, but I have a good representation, right? Okay, so now I need to look at between these, okay? I know that I need to approach this asymptote and this one. So from here, from this point that we know, am I going up towards this asymptote or down? To figure that out, again, let me just drop my marker. Okay, to figure this out, I already know I have that x-intercept. So is it going to go positive or negative? Let's pick a point. Let's pick -5 and see if my output is positive or negative. So -5, I'm going to plug in. -5 plus 3 would give me a negative on top. Over -5 plus 2 would give me a negative. -5 plus 6 would give me a positive. Sorry, Scam Likely is calling me. Okay, they're gone. All right, so on top I have a negative. And on bottom I have a negative times a positive, which would be a negative. Negative divided by a negative is positive. Okay, what does that tell me? Well, that tells me when I plugged in -5, I got a positive number. I don't know exactly what the number is again, but I know it was positive. So this guy is going to approach that vertical asymptote in the positive direction. All right, now we care even about this little space here, right? Is this going to go up like that, like a parabola, or is it going to go down towards that vertical asymptote? We have examples of both in those ones I showed you earlier, right? We have this guy where it goes down and this guy where it goes up. So you got it. We're going to pick a point in this little section, figure out if it goes positive or negative. So I'm going to pick -2.5. So if I plug in -2.5, let's see what happens. All right, -2.5 plus 3 would give me a positive. -2.5 plus 2 would give me a negative. -2.5 plus 6 would give me a positive. All right, so on top I've got a positive. On the bottom I've got a negative times a positive, which would be negative. Positive divided by a negative is negative. So that means this guy, when I plugged in -2.5, I know my answer is going to be negative. So this guy is going to approach that vertical asymptote that way. Oh my gosh, this is kind of a lot of work, but look at how lovely it is. All right, so good news, guys. I already have a point over here. So I know that this graph is not going to cross the x-axis again, right? So when I plugged in 0, I got a positive number. So guess what? This guy is going to go like this. Okay, look at that. I'm done. Oh my gosh. Okay, the last final, I said I was done. You are, but if you want to be extra thorough, the last thing you can do, which is very helpful, is to go ahead and plug this in to a graphing calculator or something to make sure you're on the right track. And if your graph comes out totally different, be like, ooh, what did I do, right? But hopefully you plug it in, you're like, oh, dang, I did that pretty good, right? Okay, I will link a whole playlist for you if you need some more examples, but I hope this helped. Thanks.